Here are some more examples on the laws of logarithms. These ones are going to be just a tiny bit more difficult than the ones in the previous video, but that's okay. Let's just get started. So evaluate each expression using the laws of logs. I see that there's two logs right here and they have the same base. That means that I can use the power law, the product law, or potentially even the quotient law. So we got to see which one we're going to use. But I just want you guys to know that if this wasn't a 4 and this was like a 5, you couldn't actually use any of the laws and you'd actually have to figure out the answer to this one, maybe using a calculator, figure out the answer to this one and then add them together and get some sort of like a decimal answer. Okay, so you wouldn't be able to put these two logs together. But since we have both the same base, we are going to put them together into a single logarithm expression. And we're going to use a product law because there's a plus in between. Okay, so log base 4, and then we're going to take the product or multiply those two right there, which is 64. In example number 1, I stopped here because I couldn't change this so that it had the base of 4. In this example, I actually can because 64 is just, well, 4 to the power of 3. That's a 3. Okay, so once we have the same base, remember how the answer to this log expression is just the exponent? Your final answer is going to be 3. Okay, so that's what I mean by being a little bit more difficult than the previous video. You just have one extra step, so it's not that hard. The next example, you got the same base, all right? There's a minus, which means I'm going to do the quotient law. So log 2, and then you take the quotient or you divide these guys, and you get 16. Again, if I can go further, I will. So this is just 2, so same base as that guy, to the power of 4. That means that your final answer for this log expression is just the exponent, which is 4. Okay, so that was when you had two logs and then something separating it. This looks a little bit different because there's only one. Now, I could actually just figure out this answer if I can figure out, like this is just 4 times a log of something. I did these questions before in 6.4, but the thing is, I can't actually make this the same base as the 16, so that's a problem. Like I can't figure out what this log equals to without the help of a calculator. What I'm going to do is I'm actually going to do maybe a backwards power rule. So I'm going to take this 4 and put it back up as an exponent, and it's going to look like this. Before in 6.4, we learned about the power rule where we actually took this and put it into the front, and it became a coefficient. So know that you can go backwards. The reason why I would do that is because 4 to the power of 4 is 256. Now that's a huge number, and I can definitely change that to a base of 16. So I can go, okay, that's 16 to the power of 2 is 256. Now that the bases are the same, my exponent is my answer. Okay, so I could figure out all of those steps without the calculator, but in this case, if I had just gone, oh, what is this equal to? Because I'm going to times it by 4, I would never be able to figure out what this is without a calculator. Okay, so let's try this now. All right, I don't have a coefficient in front, which is great. So what I'm going to do is I'm just going to get rid of this root and I'm going to write it as an exponent instead. Okay, now there's two different ways you can do this. Number 1, I can do this without the power law, and I can just go, well, let's change that 9 to the same base. So I got base of 3. Let's do the grade 9 power rule where I can put these guys together, and 2 times 1/3 is just 2/3. Now that the bases are the same, I know that my answer is 2/3. Or we can actually use the power law, and we can go method 2. I'm going to bring that 1/3 to the front. It's going to become a coefficient. Then I'm going to change that 9 to a 3 squared because the answer to this entire log, since they match, is 2. Okay, so this exponent 2 is right there. Now I'm going to multiply and you get the same answer. It's really up to you which way that you want to do. I mean, this is the method that shows you the power law, so I kind of prefer that method. But as you can see, it's a little tiny bit longer. So check out my next video on some variable examples.